Hi everyone and good morning. Welcome to the Seabridge demonstration workshops. These workshops are being run in 4 different locations, more or less in parallel, in Atlanta, Tel Aviv, Cambridge and Munich. We are hoping to convey the message of what Seabridge is capable of doing to highway agencies, departments of transport, and to the bridge inspectors, designers and engineers who work with them, to policymakers, and of course also to academics and researchers, so that all of those can understand what we are trying to achieve, what we think the benefits could be for your organizations, and how it works. Today we'll have a 4-hour session. We'll begin with a welcome and introduction. Right now we'll hear about the motivation for Seabridge and some of the background to bring everyone up to a common understanding of what we mean by building information modeling and scanning. We'll talk about the vision. Why do we think that BIM, or building information modeling, should be used for bridge management systems? And we'll also walk through the Seabridge process. The highlight of the day will be a hands-on demo where you'll be able to sit down and go through the different stages of Seabridge and see what the files look like, how it feels, and have a deeper understanding for how it works. We'll sum up at the end of the morning with a question and answer of where we are today and what still remains to be done. So what is information? What is Seabridge? Who are the partners and who are the supporters? I'll try to explain that to you in the next few minutes. Well, information is an ERANET plus European Union FP7 framework, which means that it's a pooled research fund where a number of highway agencies from Europe, the US, Israel have gotten together to pool money and to bring in matching funds from the European Union Commission itself to support transport infrastructure innovations. And we are one of 9 information programs. The information aims at cost-effective systems, advanced systems, materials and techniques, specifically for road infrastructure, and it focuses on the activities of maintenance, repair, retrofitting, and revamping. The solutions called for include technology, methods, processes, and supporting systems. And you can, of course, find more information at information.net. Seabridge is, as I said, one of the 9 information programs, but specifically, Seabridge is a process that automatically compiles BIM models of existing concrete highway bridges that includes precise information about their components, their geometry, and their surface defects. Keep in mind that there are over 500,000 bridges in the United States, more than 600,000 throughout Europe, and all of this great population of highway bridges needs to be maintained, monitored, inspected, and if necessary, repaired on a cycle that is every 2 years. So that's a daunting problem for any bridge inspection agent. The Seabridge acronym, or the name, represents 2 main ideas. Firstly, the C, as in look or see, we're talking about digital tools, computer tools that can see and measure a bridge. And the 2 tools mainly we're talking about are laser scanning, which could be terrestrial or mobile on a car or a van, and photogrammetry, which could also be still pictures, but also videos. And we're also talking about see in the sense of seeing and understanding the bridge and interpreting what they see as bridge components and defects. So we not only want to capture the imagery, we also want to interpret it and convert it into objects that we can measure, understand, and record data about. Seabridge is actually an acronym for Semantic Enrichment Engine for Bridges, where semantic enrichment is a method for using artificial intelligence tools to supplement the 3D geometry model with meaningful information. So in fact, the see and understand part is implemented through a series of artificial intelligence tools that mainly use machine learning and rule-based inferencing. So what is Seabridge and what are the steps? Well, it has 4 major steps. The first step is laser or photogrammetry and survey of the bridge, where we can use a stationary LiDAR mounted on a tripod. It has to be positioned in numerous places around the bridge, of course, because you can't see every part or every component from any given position. And it can also be mobile LiDAR used on a van. We've used the Trimble MX8 LiDAR, and in fact for the terrestrial laser we've used a number of different systems of Trimble, Leica and others. The second step is 3D geometry reconstruction, and what we're doing here is that we are taking the point cloud that results from the photogrammetry or from the laser imaging, and we're converting it into 3D geometry. That means to say that by a process of segmentation, we can identify the faces on each of the objects from the points. All the points that align on a particular surface or a particular plane can be collected together. Once we identify surfaces and find that they connect at corners or edges, we can compile them into 3D objects. This requires quite a bit of inferencing, and we have two ways of doing it, both top-down and bottom-up, and you'll hear more about that later this morning. What we're doing is called semantic enrichment. And here what we're doing is we're taking those 3D objects and we're running against them a set of rules that are essentially if-then rules that determine the different features that can exist for objects like deck slabs, transverse beams, girders, columns, etc. And we're checking whether the objects in the model actually satisfy those rules. And if they do, we're able then to classify them as those objects. Now, semantic enrichment includes 5 aspects, not only the classification as objects, as you can see here, but also automatically adding axes to the bridge, the central axis and the support axes for the abutments, columns, and so on. It also includes aggregation, in which we collect objects for the deck, we collect objects for the spans, for the column spans, and so on. We also do occlusion reconstruction, so that if there are objects who can't be seen in their full length, then we can rebuild them according to the logic of how the bridge should be. And finally, the 4th step is to identify the defects and model them. So the defects are identified from the photogrammetry. The images are compared using machine learning algorithms with images of standard defects. They can then be identified through the machine vision, measured, I won't say diagnosed, but at least identified and characterized. And then we can take the images and wrap them onto the geometry that we prepared earlier in the BIM model, so that we can observe them in the context of the model. And all of those things are what we'll try and show you today and that you have experience in trying out. Seabridge has partners who have worked on the research directly. There are 7, you can see them here. They're comprised of 4 universities and 3 other organizations who are commercial companies, Kedmore, Pointivo, and Trimble. The universities are Technion, Georgia Tech, Cambridge, and TUM. Seabridge has also enjoyed very much the support of 2 subcontractors, the Georgia Department of Transport and AEC3 Germany, both of whom have been deeply involved in the work. GDOT in representing the archetypal user or client of such a system, and in giving their advice in all the consortium meetings. And AEC3 Germany, who are a product modeling expertise company, and they have been very much involved in preparing what we call the model view definition, which you'll also hear more about later this morning. Finally, we have 3 supporters who have joined in order to provide advice, examples of bridges and so on. They are London Underground, Netivei Israel here in Israel, and the Bundesministerium für Verkehr und Digitale Infrastruktur. In fact, 2 of the workshops, today's workshop and the workshop in Munich, are hosted by these organizations. So I hope you will enjoy the morning. I hope you will find it interesting. We'll be happy to try to answer any questions, and please let us know if there is anything that's not clear. Thank you very much.